Hi, I'm Bill Snodgrass. Welcome to this episode of The World Around Us. We're doing another solubility lab. We're gonna, and if you stick around to the end, there may be this magical moment. Maybe I'm not sure. But I'm gonna try to do this. It'll look like magic, but it's just really actually science. I'm wearing goggles today. We are trying to follow the best lab safety protocols, and goggles are that. Sometimes, if you've watched a lot of my videos, you'll notice sometimes I will omit them when I'm dealing with things like household products like salt and sugar. This one we're using magnesium sulfate and distilled water. We're going to dissolve the magnesium sulfate in the water. We're going to try to create a saturation at around room temperature, which will probably be it looks like we're around about 21 right now. And then we're going to raise the temperature to 80 and try to increase the amount of dissolved, try to reach saturation there. And then we'll let that cool down and see if we can get some magic to occur. So that's what we're doing. That's the plan. We're going to look at solubility of magnesium sulfate at 2 points, in the temperature scale, 20 and 80. If you're doing this as a virtual lab, then we'll go through and we'll collect all the data, and then we'll stop the video, and then we'll calculate, which will not be that complicated because we're using 100 milliliters of water and we're using grams, so the results will almost be the calculation, or so they'll be very simple calculations. In the discussion section, however, you'll have more to write there. We'll talk about the conclusions and the discussion, and then we'll see if the magic moment occurs. I've talked enough. Let's get started. All right, 100 milliliters of distilled water, carefully measured out in a graduated cylinder, and I measured that out before I turned the camera on. So I'm going to pour it into the beaker and try to get every drop out. All right. I have a stir in there. I'm going to turn the stirring thing on, magnetic stir. I have my thermometer placed so that the bulb is in the water, not being hit by the stir, not touching the bottom of the hot plate. I will turn it on. All right, I'm going to begin weighing out. Look at the weighing boat. I'm going to zero the scale. And I'm going to just transfer some into the weighing boat until I get a few grams. And that is 5.43. All right, we will weigh out another measure. Zero the scale. And that is 7.37. Once again, I'm working on the back side of the apparatus, which introduces a number of problems and issues. All right, we're going to continue to add different measures of the magnesium sulfate until we get, so I'm not going to make you watch me go through all these steps. All right, we're at 31.27 grams at, we are currently sitting at 19 degrees. I want to zero the weighing boat, put in some more into the weighing boat. That's more than I was hoping to measure out. I'm going to put some of it back. Well, that's 2. Let's go a little less. So that is 1.8. 1.79. I always like how the scale tricks me. 1.79. We're going to add this 1.79 into There's currently 31.27 in there. We're adding another 1.79. We are getting close to saturation. We are getting close. I'm going to turn the stir down just for a moment. And if you look real closely, you can still see that there is a very clear solution. The solution is very clear and unstained. In another video I did with sugar, the liquid, the solution color began to take on a caramel appearance. And various stages in the mixing process, there was suspension. It was cloudy. There was suspension still going on. But in this case, we still have a very clear suspension where the solute is completely dissolved. So we're going to add some more. So we're going to zero the weighing boat. 1.10. 1.10. We're going to continue to add. Determining that it is saturated relies on looking and seeing if there's any like crystals lying on the bottom. If there's any crystals that are undissolved in the solution. And when mixing, it introduces air bubbles in, which makes the subjective observation, the visual observation is somewhat a little bit challenged. I'm going to measure out a little bit more. All right, we're going to zero the weighing boat. Zero. Let that stir. I'm going to try not to introduce air bubbles. Let it stir for a moment. I'm beginning to see granules on the bottom. So I'm going to turn the stir off and observe that. And yes, there are indeed granules on the bottom. So just kind of to make an average there, I'm gonna count about half of that as having dissolved. And let me do a real quick calculation, see what we come up with. I'll be right back. All right, at the temperature reading of 19 degrees Celsius, I have 34.9 grams total dissolved. So now we're going to raise the temperature we're going to try to raise the temperature to 80, and then we're going to see how much more we can add to it at that point. So we're going to try to raise it. So we'll turn the hot plate on, let this heat up, and I'm trying not to let it get above 80, and then we'll see how much more. So at our experimental value at 19 degrees Celsius was 34.9 grams of magnesium sulfate into distilled water. So there's your a data point. There's a piece of data you can collect for your if you're doing the virtual lab. We'll be back when this heats up. All right, as the temperature has increased, I've been adding solute into the solution. I've been adding the magnesium sulfate in, and currently we're closing in on that 80 degree mark. We're at 51.9 grams. And I added back in the portion that I counted as not dissolved at 19 degrees. So we have, at this point, we have a total in the beaker. We have a total of 51.9 grams. We should be able to get a little bit more in theoretically if the charts and things are correct. So let's see what happens if we can do a little bit more. Let's see check that temperature one more time. And I'm going to turn this down to 45 because there's all the residual heat in the hot plate. Don't want it to go over. It might go over a little bit. All right. Get a weighing boat here, zero that out. We're at 51.9 and we're going to add in, we'll add in another gram or so. And that's 1.3. 1.3. We're going to continue to add small increments until we get to that saturation point. All right, we're getting really close. The temperature it's really close to 80. We'll read it at the final. I have a suspicion that this is gonna go beyond, and that's 0.5. You know, you get lucky that lucky. We're just gonna go with that 0.5 grams more. What's going to happen? I'm seeing the things that are not dissolving, and if I had any doubt before adding that, I have no doubt at this point now that I thought for a second there we were done. Zero the boat. Weigh in another small portion. .65. See what happens. Did the temperature go up any? We are still really right at 80. Yeah, and there are definitely grains that are on the bottom of the beaker at this point. Let's see if we can see that on the other camera. There's a couple right here in the back that are not dissolved. And let me do some math. I'll be right back. All right, adding it all up, I come to at 80 degrees, I come to 54.9, 20 grams more than when we were at 19 degrees. At 80, I guess I should double check that temperature, make sure. All right, at 80 degrees, I just checked the thermometer. At 80 degrees, we were able to get 54.9 grams of magnesium sulfate into the water at 80 degrees. 54.9, and that's 20 more grams than at 19 degrees. So what I'm gonna do, I'm gonna turn the temperature back up. I'm gonna add a little bit more. I'm gonna get it, make sure that all that's in there is dissolved, and then we're gonna let it cool back down to room temperature. And then, whenever that happens, when it cools back down to room temperature, we're gonna try the last thing, because we'll talk about it in the discussion. That was a pretty articulate moment for me there, wasn't it? So it'll cool back down, and we'll see what happens, because there's 20 grams more now than there was at room temperature. We want to see what happens when it cools back down. So I'm going to put a little bit more in just to get it oversaturated. Not that we're not measuring anymore, we're just looking for a phenomenon called supersaturation. So I'm going to let that dissolve, and then we'll turn the burner off and let it cool down, and we'll see what happens from there. All right, a couple hours have passed. The temperature of the solution has gone back from, it was at 80 when we last measured, at 54.9 grams of solute, magnesium sulfate. The temperature is now at 25. The temperature is now at 25 degrees Celsius. If you're doing the virtual lab, then one of the questions is, when the temperature returned back to room temperature, what happened in the solution? Because remember, at 19 degrees, we had 34.9 grams. At 80 degrees, we had 54.9 grams. We put 20 grams more in. Then I heated it a little bit more, and I put a little bit more magnesium sulfate, and I want to get everything dissolved so that there was no undissolved magnesium sulfate. So I got the temperature up to about 90, put a little bit more in, a few more grams, and now it is cooled down to 25. So there is well over 20 grams additional than there was at room temperature. So if you're doing the virtual lab, one of the questions says to record what you observe when the solution returns back to room temperature. So here's your observation. Nothing happened. We're going to talk about that in the results section, which is going to follow. We're going to talk about why nothing happened, what is going on here. So we're going to talk about that in the discussion part of this video, which is going to follow. This is your results. So the results were at 19 degrees, 34.9. Raising the temperature to 80 degrees, we got to 54.9. Letting it cool back down to room temperature, we still have over 54.9 grams. Nothing changed from the 80 degrees back to room temperature. That's it for the results. Now the discussion is the most interesting part, and the magic that may or may not occur. I don't know if it's going to occur or not. Honestly, I don't know if it's going to occur. I've never tried it, but that'll come after the discussion section. All right, so if you're doing the virtual lab, there's your data. One last time on the data: 34.9 at 19, 54.9 at 80, and then when it returned to 25 degrees Celsius, all of it's still dissolved in there. It's all still dissolved in there. And what does that mean? All right, so we move on to the discussion section. Be right back. All right, that was the results section. That was our results. Now let's discuss a little bit of what we saw. So in our results, we recorded at one temperature. We had at 19 degrees we had 34.9 grams. At 80 degrees we had 54.9 grams. We heated it up a little bit more to make sure that everything got dissolved. Put in a little bit more in, so we have over 20 grams more now than we started with at 19 degrees. The temperature has fallen back to 25 degrees, but all of that is still dissolved in the solution. Now, what we learned in the results is as the temperature goes up, you can dissolve more in it. And then we observed what happened after you have dissolved all of that and the temperature comes back down. What happens? Well, nothing happened in this case. With magnesium sulfate, the temperature came down, but all of the extra 20 grams stayed dissolved. So what we've created is called a supersaturation, and this is exactly how supersaturations are created. Is you saturate a solution at a high temperature, and then you lower the temperature back down, and all of this extra stuff that we dissolved between 25 and 80, all of that extra stays in the solution. Now, why is that? So I'm going to depart a little bit from the science and go a little bit into a metaphor. So if this were like a room, and there's all this, let's say 55 grams of magnesium sulfate are in the room, and then the room becomes smaller. And the magnesium sulfates are looking around going, hey, there's not enough room for all of us. One of you guys has got to precipitate out. There's not enough room for you to stay in solution. And the other guy's like, I'm not going first, you go first. And the other guy goes, I'm not going first, you go first. So no one wants to go first. No one wants to be the first one to precipitate out. Now, I don't know if it's going to happen with magnesium sulfate, but in other solutes, if you reintroduce a crystal of the solid, so the crystal matrix, the crystal lattice, is sometimes they're complicated for the molecules to get in, and if you introduce a piece of that crystal lattice, then all the other molecules goes, oh, that's how we're supposed to do it, and they all will form in together. And it will sometimes, I don't know if it's going to do, I honestly have never tried this with magnesium sulfate. This is first try here, but in other solutions, then when you drop it in, it happens.
Dropped it in there?
Oh,
It looks like a puff ball.
Let's find out what happens. So I'm gonna get my scopula. I'm gonna get my magnesium sulfate, and I'm gonna find a single crystal, a single grain of salt. I got about I don't know, 8 or 10, I don't know how many's on there. There's several, not one, because, and when I put it in, let's see what happens. It may do nothing, it may, I don't even know. Let's find out what's going to happen here. Those grains have gone to the bottom and they're just sitting there. I don't know how fast it should have happened. Let's just let this roll for a minute. I'm going to move this camera in closer to get a closer angle on it. All right, so this camera is obviously looking directly down into the beaker. And the grains that I put in did not seem to be doing anything particularly quickly. So we'll let this run for a couple of minutes and see what happens. I'm going to introduce a couple more crystals from the dish so that we can compare the size that is in there now with the size that's in the dish. I'm going to try to get them to be on this side. It'll be on the right side of this video. Try to get them to go in there. So you can see the two that I just put in. And I just don't feel like it is conclusive to say that the other crystals have grown. So no magic, or we're going to say there's no magic in this one. But, all right, it is the next day from when I was but this is the next day. It's the next morning when I arrived. I let it sit overnight. I didn't disturb it, and the room temperature dropped. It was about 15 C when I got here, and I looked in, and I was like, oh man, there's something on the surface. Oh, and then I looked more closely, and then I could see that in the solution, those crystals that we talked about, possibly, the rapid recrystallization, well, it wasn't very rapid, but recrystallization did occur. So as the temperature fell, those particles of magnesium sulfate that were supersaturated, they got to the point, it was like, somebody go first, and there were some other crystals that we put in there. Around those crystals that we put in there, the supersaturated magnesium sulfate particles began to attach, and we created these little crystal sculptures, if you will, the crystals that formed inside the solution. So there it is in the magnesium sulfate, just like we thought, only just not as fast as we had hoped. All right, so that is what could have happened rapidly. So no magic, or we're going to say there's no magic in this one, but we do have the supersaturation, and we did accomplish that by raising the temperature, adding more and more into it until it was saturated, and then lowering the temperature back down, and until we added this extra stuff back in at room temperature, which isn't dissolving. And we know there's already 20 extra grams that were dissolved in there in the first place. So that is why these are not going to dissolve, because there's already too many in there to begin with. So that we have accomplished supersaturation. At least we have seen that adding more now does not cause any more to dissolve. We can't get any more to dissolve because it's already supersaturated. All right, well, it would have been awesome if we'd had a very dramatic recrystallization, but that didn't happen. But you can like the video anyway, and as far as a study on supersaturation, we have accomplished that. Thank you for watching. Please click the like button, subscribe to the channel, sign up for notifications, leave me a comment, question, or suggestion. That is all for this episode on magnesium sulfate saturation, supersaturation. There you have it. See you in the next one.